today we're talking about other shapes that have a different number of sides. So up until this point, we've talked about a triangle, which has 3 sides. We've talked about a quadrilateral that has 4 sides. So now we're going to be talking about something, shapes that have a different number of sides. So the first vocabulary word is polygon. It is a closed figure, closed shape, whose sides are line segments that intersect only at their endpoints. A regular polygon, as opposed to not a regular polygon. A regular polygon is obviously a polygon. I'm abbreviating with all sides equal in length and all angles equal in measure. So basically, if you think about it, it's kind of symmetrical. Now, the rest of the vocabulary words have the Latin root, or the Latin prefix, where the first part of the word means the number in Latin. So you've got a pentagon, which means 5. Okay, so a pentagon is a polygon. With 5 sides. A hexagon is a polygon. With 6 sides. A heptagon is a polygon with 7 sides. And an octagon is a polygon with 8 sides. Yep.
That's what we call an octopus. An octopus is like the
8. Yep. And then the pentagon that we have in the United States, the government control offices, it's got 5 sides. It's shaped, if you're looking at it from the top view, it's shaped just like a pentagon with 5 sides. Okay, so example 1 is just identifying, are these shapes a polygon, a regular polygon, or not a polygon at all? If you look at A is not a polygon at all, because you've got line segments that intersect beyond the outside of the figure. So because, now if these lines right here, if they would not have drawn those, then yeah, if you couldn't see those, it would be a polygon. But since we can see those, it is not a polygon. So we would say not a polygon, and then we would say something along the lines are because the sides intersect at places other than just the endpoints. So that's not a polygon because they've got line segments that are intersecting at other points just besides just where the points end. So that's not a polygon. not all equal. So it is a polygon, but it's not a regular polygon. So we would just say that it's not a regular polygon because the line segments and angle measures are not equal. So that. Alright, so last page. The last page, you remember, anytime in our notes we get a box that has information, that box is where some important information is. So you can see right here that we've got a box and it's got some important information. So this is a formula that you guys are going to have to memorize so that you know how to use it when solving problems. So it says angle measures in a polygon. And these little boxes outside here always tend to have some really good information too. And it says you can use an n-gon, where n represents the number of sides to identify any polygon if you haven't learned its name. So beyond octagon, I don't know that they're named. Like I don't know that if it's a 9 or 10 or 11 or 12 or 51, there's no name for a polygon that has 51 sides. Does that make sense? So we've got triangle, which is 3 sides. We've got quadrilateral, which is 4. And then beyond that, we have 5, 6, 7, and 8. Okay, but if we want to name one that has more than that, here's how we do it. Now the angles, the sum of angle measures in whatever polygon this is, or however many sides it is we take n minus 2 times 180. So n being the number of sides. We subtract 2 and then multiply times 180 degrees. Alright, and that tells us what those angles add up to be. And then if we want to find the measure of one angle, we take n minus 2 times 180 and then divide it by the number of sides. Okay, so we'll see what this looks like here in a second. Now, obviously in example 2, we can count those sides, and that counts out to be what? So we know that 6 is what? Hexagon. It's a hexagon. Okay? And so it tells us that a regular hexagon, we know, has 6 sides. So how many sides is it? 6. So n would be what? 6. Now, to figure out the measure of one angle, so I want to know the measure of one angle, I'm going to use this formula right here. And one angle would just be like right here. Okay, one angle. So I'm going to take n minus 2 times 180 divided by n. Now, which number am I going to replace n with? 6. So I'm going to take 6 minus 2 times 180 divided by 6. Now, I know what 6 minus 2 is. That's 4. And then when I take 4 times 180, I get 720. And then when I take 720 and I divide it by 6, I get what? 120. So one of these angle measures is 120. But if one of them is 120, guess what the rest of them are? 120. Okay, because this is a regular polygon. What do I know about a regular polygon? The side lengths are equal and the angles are equal. Alright, now, last 2 examples. Now, I don't remember off the top of my head. How many sides did that have? 7? Okay. So if they're asking me, find the sum of the And what number am I gonna replace the n with? So I'm gonna take 7 minus 2, which is what? 5. And then 5 times 180, which is 900. So all of the angles in a heptagon would add, a regular heptagon, would add up, or in a heptagon, it didn't necessarily have to be regular, would add up to be 900. Now, it asks me in number 2, and this would have to be, in this case, it has to be a regular polygon, they all have to be equal. Find the measure of just one angle in a regular 12-gon. No name for 12-gon, okay? But if I wanted to find the one angle measure, which formula did I use? The top one or the bottom one? The bottom. So, which is